I am Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm here with Eli Roth of Teradyne. We're going to talk today about secure movement of data in test. Eli, one of the problems that we're starting to see as we move into complicated chips, particularly heterogeneous chips, is that we have lots of different vendors in there. Now we have to worry about moving data back and forth. What sort of problems are you seeing, and are they getting worse?
Yeah, historically, we had data created into an STDF file that was packaged and loaded into some data source. What we're seeing today is the need to stream data in real time into different data consumers throughout the test floor. And doing that as fast as we can and securely as we can is a real challenge that we're trying to face.
And as we get into the chiplet world, this becomes even more problematic, right? Because now you have lots of little companies that are worried about, oh, this is my only IP. I have to safeguard this as best I can.
Sure, IP protection, data security is really important in this space.
Let's take a closer look.
Sure.
Eli, what are we looking at?
What we're looking at here is a really simple model of how data flows today. Our data is generated on the tester, and you can stream data with the TIM standard, either to an IT solution or to a cloud solution, or through an edge device, and that's how you can move data in a streaming system.
What happens with the data that's on the tester? Does it stay there? Does it move around? And if so, why?
Historically, data was generated into large data files that were sent off the tester and sent into some mass storage system. Today, we're streaming data in real time, and the collectors or the subscribers of that data can be numerous.
And that data is a lot more valuable than it was in the past, too, right?
Right. The data is being used in real time to make real time decisions that are affecting your test insertion on the fly.
You also have to collate that data in one way or another as well. What happens with that? Because really what you're trying to do is say, okay, we're going to keep all this data as secure as possible. If it's different vendors, we're going to keep it as secure as possible and not involve anybody else. But the reality is you're integrating a lot of pieces here.
Sure, there are a lot of pieces being integrated, and we want to make sure that that integration happens away from the tester itself so as to not impact test time or tester performance.
You mentioned test time. That's a really interesting thing here because with data, if you're not sharing it easily or it's difficult to get to that data, that really slows things down, right?
Yeah, it definitely slows things down. And historically, data has flowed from the tester out to some other source. The challenge now going forward is to bring data back to the tester.
If you do that wrong, your cost goes up for how much you're actually spending on tests too, right? Test time as well as the actual testing.
Sure, customers are using big data solutions to save time, increase throughput, improve quality. So adding test time due to a poor data strategy is counterproductive.
Does this give an advantage to the big IDMs that are developing the chiplets internally themselves?
Yeah, they have a great advantage because they've got a lot of data right in their own resident facility that they can move in and out of the test system at their own decision.
And so the big challenge for the fabless model is you really have to be able to come close to what the IDMs are doing so that you can remain cost competitive, right?
Sure, you've got a cost competitive concern, and then you've also got data being generated outside of your facility that you want to be able to look at it, see it, in as close to real time as possible.
Who owns the data that comes on the tester?
Everybody's always asking who owns the data, but the data is owned by the customer who's generating data off the tester.
And what happens to the data after it comes off the tester?
The data can go to a number of places. One, we still support the standard test data format that has been used for decades in the test industry, but the data can also stream to any number of data consumers, and the customer can define those by any network application that's on the same network as the tester.
And you have a tester there, but there's a lot of different testers too, right? So you've got system level test, you've got the classic burn-in type stuff. What's the difference in terms of how that data is shared?
So we find it really important to get data off the tester as fast and as securely as possible. And so we support a data standard that's called TIMS to stream data to any consumer on the system.
And it really doesn't matter what kind of test you're doing?
No, it doesn't matter what kind of test.
Where do people typically run into problems with this?
They run into problems when they try to run things on the tester that consumes data resources, or they try to make data decisions far away from the tester, and the latency from the tester to their IT solution is too far away, it takes too long, and they can't make real-time decisions.
And Data in motion is always more vulnerable than data at rest, too, right?
Of course. And so data security is always top of mind. And so there's data that has IP protection or trade secrets that really has to be secured.
Once the data comes off the tester, you said you want to get it off as fast as possible. Where does it go next?
Well, the data can go to some model somewhere, and that's often on a cloud solution or on an IT resource within the test floor, or we can put it onto an edge device so where you can make real-time decisions in the test cell.
So let's go back a step here. You're talking about security on the data, but a lot of this stuff is very new. You think about some of the algorithms that are being used. Some of the adaptive tests has been around, but it really hasn't been used for the same type of purpose. How does that change here?
The models that have been used to date are relatively simple and don't have a lot of IP concerns in them and not a lot of computational memory demands. But as we get more sophisticated in this space, that the models themselves and the data flowing into those models are very proprietary and have a lot of IP.
So reliability does carry a cost, is what you're saying.
Reliability and security always carry a cost.
What you're talking about is typically a feed forward model. There's a feedback model that comes in here too, right?
Yes. Now that you've got a model somewhere that is consuming data, you want to have some behavior back to the tester. And so in the past, this has been a one-way stream, but now the tester is actually turning into a data consumer as well, as results from the model feed back from the edge device or back from your IT solutions into the tester and change the way the tester behaves.
Does that change the insertion points of where you're testing as well?
The infrastructure doesn't change the insertion points itself, but it can change the way the test flows in an adaptive test model.
Eli Roth, thanks for a great explanation.
You're welcome.